Welcome to The Explainer. Today, we're going to pull back the curtain on the science behind our food. We're uncovering a hidden mathematical formula that can be the difference between a healthy, thriving farm and one that's really struggling. And believe it or not, this whole story starts with a chicken.
You know, for poultry farmers, every single day is a massive, high-stakes balancing act. I mean, think about it. They're managing the health of literally thousands, sometimes millions of birds. Just one tiny thing goes wrong, one little imbalance, and you can have these huge, widespread problems that affect everything from how fast the chickens grow to the quality of the eggs that end up in our kitchens.
So what if the answer wasn't some new, fancy medicine or a complicated treatment? What if a whole bunch of these problems could all be traced back to one single invisible factor? Not a germ, not a virus, but a simple mathematical balance hidden in the very food the chickens eat.
All right, so before we jump to the answer, let's really get a grip on the problem here. What are the actual everyday challenges that this hidden formula can help solve?
On any given day, a farmer might be dealing with a whole laundry list of issues. Birds that just aren't gaining weight properly. Eggshells so weak they break if you look at them wrong. Or this condition they call wet litter, which is, yeah, exactly what it sounds like, and it creates a really unhealthy environment for the birds. Now, on the surface, all these problems, they seem totally disconnected, right?
Well, this is where we get our first big clue. So on the left, you've got a graph showing that wet litter problem. On the right, a graph for eggshell quality. Two completely different issues, but look closer. As this one specific value along the bottom, this dEB, as it changes, both problems seem to react in a really similar way. This is our first big hint that these things are connected.
And that really begs the question, doesn't it? We can see its effect pretty much everywhere. But what is this mysterious dEB that seems to be pulling all the strings?
And that brings us right to the science. It's time to unlock the code behind this incredibly powerful idea.
dEB. It stands for Dietary Electrolyte Balance. Now, in plain English, it's not just about what electrolytes are in the animal's feed, but about their precise mathematical balance relative to each other. This balance is absolutely fundamental for regulating an animal's internal chemistry, specifically something called its acid-base balance.
It all comes down to these three key minerals or electrolytes. Think of them like tiny little batteries. You've got two with a positive charge, sodium and potassium, and one with a negative charge, chloride. Now on their own, they do vital jobs, regulating water, making sure muscles and nerves are firing correctly, but their real power comes from how they're balanced together.
And here it is, the hidden formula. And it's so beautifully simple, isn't it? You just add the two positive guys, sodium and potassium, and then you subtract the negative one, chloride. It's that final number, that delicate balance, that makes all the difference in the world.
So if it's all about balance, what does that perfect balance actually look like? Well, this is where we enter what scientists call the Goldilocks zone. Not too high, not too low, but a precise range that just unlocks peak performance. And the data? Oh man, the data makes this incredibly clear.
Okay, let's start with growth rate. This chart shows the dEB value along the bottom and how fast the birds grow up the side. I mean, you can see it clear as day. If the dEB value is too low, growth is stunted. If it's too high, growth suffers again. But right there in the middle, that highlighted peak, that's the sweet spot.
And it's the exact same story for feed efficiency, which is basically just a measure of how well a bird turns its food into growth. The graph shows the same beautiful peak. When that dEB is in the Goldilocks zone, the bird's metabolism is just running at its absolute best.
So, why does this happen? What's the secret? Well, this chart gets right to the heart of it. It's showing blood pH. Now, a stable pH is absolutely critical for an animal's health, and once you know it, the optimal, stable range lines up perfectly with that same Goldilocks zone for dEB. This balance is literally keeping the animal's internal chemistry stable.
And we're not just talking about a general idea here. The science is incredibly precise. For broiler chickens, the ones raised for meat, that target number is right around 240. That number represents the ideal electrical charge balance in every single kilogram of feed. It's an incredibly specific scientific target that animal nutritionists work tirelessly to hit.
But, and this is a big but, achieving and maintaining this perfect balance, well, it's not as simple as just following a recipe. It is a constant, delicate balancing act.
I mean, listen to how one expert in the field puts it. This relationship is both complex and often misunderstood. So what makes hitting that perfect number so darn tricky in the real world?
Well, the challenge starts with the most basic ingredients. Just look at the huge variation here. Maize has a dEB of about 71, but then soybean meal is way up there at 478. A nutritionist can't just swap one for the other. Every little change requires a complete recalculation to get back to that 240 target.
And it's not just the ingredients either. External factors are constantly trying to shift the balance. For instance, heat stress makes birds pant, which actually changes their blood chemistry. Even helpful additives that are put in the feed can throw the dEB off. It's this dynamic, ever-changing puzzle that needs constant attention.
So, after all this complex science, what's the real-world payoff? Let's look at one of the most tangible results you can literally hold in your hand, the perfect egg. The data on egg production it's crystal clear. This study shows that the hens fed a diet with that optimal dEB level, right there in the middle, produced the most eggs. When the balance was too low or too high, production just dropped off. The numbers really don't lie.
And it's not just about the number of eggs, it's about their quality. This final graph shows a direct line between that optimal dEB and the thickness and strength of the eggshell. It's the perfect example of how this invisible chemical balance produces a visible, high-quality result that you can see and feel.
And that really is the key takeaway here. What might look like a simple farm is actually a hub of incredibly precise science. Modern, healthy food production isn't about guesswork anymore. It's about understanding and applying these hidden formulas to get the absolute best results. And that leaves us with one final thought to chew on. If a simple mathematical balance can have such a profound effect on the health of an animal and the quality of our food, it really makes you wonder, what other invisible science is hiding right there on your plate?